Can you fix that with AI, Bill? So you said we have to find the problems and then figure out the solutions, the nails before the hammer. What are, say, top 3 problems on your mind that you'd love to figure out solutions for?
Well, one of the reasons I think the TB example has worked so well is we've known for a long time that if we can find the people with TB, we can treat them. The trick is, how do you find the people with TB? So we had this glaring problem, and that's been, I think, led to very focused use of AI to solve that particular issue. There are a host of other problems, and this is where we need a kind of dialogue between health people and the software engineers, because in a sense, the health people don't quite know what the tools can do, and the software people don't necessarily know what the problem is. But I'd give you another example. We have increasing instance of resistance, malaria being resistant to current first-line treatments, so artemisinin-based treatments. And in somewhere like Rwanda, where we have very sophisticated disease surveillance, genomic sequencing of malaria cases and so on, we know what's going on. The trouble is, if you go to Burundi or DRC next door, we don't know what's going on. And understanding the patterns across the continent of where resistance is and what type of resistance is occurring seems to me like a problem where AI could be incredibly useful. And it's really important because, to put this in perspective, in the early 60s, our main treatment was chloroquine. We had chloroquine resistance. We had a massive surge of deaths, and the whole kind of malaria project was put back. We know something similar is happening now with artemisinin resistance. We don't know enough about it. And that, to my mind, is a good example of a problem I'd love to use AI to help us address.
Can you fix that with AI, Bill?
Well, you can understand, looking at all that genetic data, where you look at the mosquito genetics and the parasite genetics, yes, you can.